It's like 2 pages. Like 2 pages for me, which, you know. I'm a little all over the place with my stuff. So. A little bit more than that, but. Okay, so the first one's find the domain of the function. Use limits to describe the end behavior of f at the values of x not in its domain. So number 2.
I don't know what the directions mean.
F of x. It sounds really complicated for something that's literally like a 2-line answer. F of x is equal to -3 over x minus 1. So basically, where can this not exist? What can't be true of this?
X can't equal, 1.
Okay, but why?
Because
What's wrong with it? Okay, because that would make the denominator equal to 0. So we're trying to eliminate anything that makes the denominator 0.
So do like the domain thing again?
So just to show, what is happening? Just to show what's happening, yeah, basically. So x minus 1 equals 0, so x equals 1. So that means that the domain is everything except for 1. Sometimes there will be multiple numbers, but in this case it's just the 1. So our domain we write as -infinity to 1, union 1 to infinity. So all numbers except for 1 work.
How do you make your infinity signs look good?
You just don't.
I've done them for a really long time. Literally just a sideways 8.
Yeah,
You turn your paper to the side and then you write an 8.
Basically.
Oh.
I used to do that, but then it got really irritating because I felt like they were like not straight, and I don't know. I just
And like they're like lopsided.
now I just do it a lot, and I used to just sit and just like draw them all the time and just
Practice.
yeah. While
Weird.
Mr. Cass was talking, I just my notebook from his class has a lot of doodles in it. Because inevitably there would be like some mistake or something that would happen, and like we would catch it, but we like wouldn't say anything, which like would make him really mad, and I felt bad, but it was fine. If we like really wanted to do math that day, we would tell him, and if not, we'd wait till he got to the end and be like, "Oh, I think there was a problem over there." I get a little irritated if people tell me till the end of a problem, but I guess it's just coming back to bite me now. So
it was really funny to point out was when Mr. Hall was teaching us, he'd like play something and then he'd start talking, but he was on mute. So we just have to be like raise our hand and then we're like, you're on mute, and then just like, oh. He'd say like a whole thing and all of us are just like in the chat being like, you're on mute, man. So finally someone's like, okay, you're on mute.
all right.
Just straight.
So, use limits to describe the end behavior of f at the values of x not in its domain. So, any value of x that's not in the domain, so in this case it's 1, we're going to look at the left and right hand limit of that, and we're going to say what happens. The answers are either negative infinity or positive infinity. They can both potentially be the same answer. So don't just assume that you got negative infinity for one, the other one has to be positive. Actually look at the problem. Okay?
That's sad.
So we're looking at the limit as x approaches 1 with the negative sign means from the left. Okay, remember negative's on the left, so if we do that, it's from the left side of f of x. And we want to know what it's equal to. So 1 from the left, I'm looking at something like 0.999999. Okay, so you're going to put that number in for x. Okay, you're not actually putting it in. You're just imagining what happens. So if I subtract 1 from that, what do I get on the bottom? A positive or negative number? Negative, right?
Yeah.
Okay. So negative divided by negative,
It's positive.
so it's positive infinity.
Oh. Okay. That makes sense. Oh, that was really ugly.
And then on the other side, the limit as x approaches 1 from the right, so it's got a little positive sign up there of f of x. So now we're looking at something like 1.000001. Okay, so you're looking for something really, really tiny that's close to it, like with a tiny difference is what I should say.
That'd still be
I thought it was
negative, right?
big. Like last, wasn't it?
They're
big?
different things.
That'd still be negative, right?
Well, so I have a number a little bit bigger than 1,
Oh, bigger
minus
than
1
Bigger than 1.
gives you what? A positive on the bottom. So a negative on top, positive on the bottom is
Negative infinity.
negative, so it's negative infinity.
Never mind. So it has to be bigger than 1. Something bigger.
Slightly, yeah. So basically you're looking at a number a little bit smaller and a little bit bigger.
Okay.
So if we'd had two numbers, we would have done this twice, basically. So the things that you're looking for with what this problem is asking for, you're looking for this domain, and then you're looking for both of these limits here. Okay, are the two things that these problems are looking for.
Okay. I still can't circle things, even with the so it's a helper thing.
All right. And actually, if you did have two numbers, you only technically have to do it for one of them. I won't make you do it for both. So that will just make it easy. Less space. All right, so number 4, f of x is equal to 2 over x squared minus 1. So I want to find the domain. So what values am I looking for? So then I've got x squared equals 1. So x equals plus or minus 1. Okay, so my domain is everything except for -1 and +1. So the correct way to write this, domain -infinity to -1, union -1 to 1, union 1 to infinity. So that accounts for everything except for -1 and 1, which are the two things where it can't exist, okay? Because of the parentheses, that means everything except for that.
Can you scroll back up the elder domain really fast? I think I wrote it wrong. Yeah, I definitely did. Okay, thank you.
Somebody got a line.
What?
Somebody got a line. Anyways, I'm sorry. I'm just. all
I
over
was
the
like,
place
what
right
are you
now.
talking about? Oh yeah, I bought more. Okay, so they didn't have the little mini packs of chocolate donuts, but they had the 6 packs of chocolate donuts, and I felt like people tend to buy 2 packs of chocolate donuts.
Yeah.
So they're just gonna be $1 instead of 50 cents because there's 6 of them instead of 3. So just FYI. Random side note.
Yeah.
They look really good. I'm like kind of want some, but it's fine. Okay, so now we're gonna look at the limits. So I'm gonna use 1 just because it's easier. If you have the option to use a positive number, use a positive number. Most of the time it's easier instead of having to think about -0.000, whatever. So the limit as x approaches 1 from the left of f of x. So again, 1 from the left is like 0.99999. So
Is this going to be the same as the last problem?
basically, yeah. I mean, the way you do it, yes.
Positive.
Yeah.
Well, you have to imagine what's happening if you do like, if you need to use your calculator, you can, because
You have to square.
you need to, yeah, you have to square it. So this one's a little different because you have to square the number. So do something like, not like 5 nines, like so point, and then 5 nines, and then square that, and then subtract 1 and see what happens.
Oh.
It's negative.
So that makes the bottom negative. So positive over negative.
Negative.
Okay, and you can use your calculator on the other ones to test a number if you want. Like I don't care. But ones that are being squared, you definitely would want to use a calculator to check it, because it can be confusing when a number's being squared. So then we would also do limit as x approaches 1 from the right of f of x. So do something like 1.0001 squared. And then you can subtract your 1. So you're going to end up with a positive over a positive, which is positive. It's positive infinity. So again, these are the 3 things here we're looking for.
I really did this school.
Well, I didn't like doing it online. That's for sure.
All right, next one's describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function Identify the horizontal and vertical asymptotes and use limits to describe the corresponding behavior. Kind of modifying it in that you don't have to explain how it's being transformed. Okay, I just want to know vertical, horizontal asymptotes, and then the in behavior stuff. The in behavior stuff, we're going to be doing the same stuff like we just did here with these limits, and then we're going to do the other limits for the horizontal asymptotes where you're plugging in infinity or negative infinity and getting out a number. Okay, like, where is it? Like this. The horizontal in behavior stuff. So we're going to be doing both kinds of in behavior with these ones. So number 8, f of x is equal to 3x minus 2 over x minus 1. So we've done vertical and horizontal asymptotes for a little while now. So where would my vertical asymptote be?
1. Wait, no, 3. Right? Wait. Okay, well, they're both the same.
Vertical asymptote.
I'm looking at the wrong thing. Never mind, give me a minute. Oh my goodness, it's just one.
Where do the vertical asymptotes occur, or, yeah, where do they occur?
I feel like this is wrong, but isn't it
Both the same, use the coefficients,
Yeah, when the,
right?
nope, you're still on
It's equal to
horizontal.
0?
Yeah, so when the denominator is equal to 0, so it's the same way we were finding domain. Okay, so where's the denominator 0 when x is equal to what? Okay, so vertical asymptote is at x is equal to 1.
Oh,
Horizontal asymptote, okay, back to your clown poem.
no. Now it's y plus 3.
Okay, y equals 3. Both variables are the same power, so it's the coefficient in front.
There we go. Now I remember.
Both the same, use the coefficient. So then what we're going to do is we're going to do the limits, okay, for the vertical asymptotes with these, the limit as x approaches 1 from the left and right. And then for the horizontal, we're going to look at the limits at negative infinity and infinity, and they have to be equal, okay? So for vertical first, the limit as x approaches 1 from the left of f of x is equal to what? So if I put in like point, now notice because you have an x on top and bottom, you got to pay attention to that. So you might really want to plug it in to your calculator and see kind of what you're getting, positive or negative at least, because you know it's got to go to infinity. But if I'm plugging in a number, 0.99999, the bottom is what? Bottom's negative. Top 3 times 0.99999 is going to still be a number bigger than, well, not a number bigger than 3. It's still going to be bigger than, it's still going to be positive, but 3 times should be like 2.999. So yeah, it's still basically the same thing. So then minus. So it's positive on top, negative on bottom. So it is negative infinity. Limit x approaches 1 from the right of f of x. So from the right, 1 point something. What do I have?
Positive on the bottom and positive on the top.
Yep, positive top, positive bottom. So that one's going to infinity. So then the next one is a little different than the other ones. Okay, again, I'm going to scroll back up here so you can see this horizontal in behavior. So the limit as x approaches in negative infinity and as it approaches infinity is always going to be. It's going to whatever your horizontal asymptote is. Okay, so the way we write this one is the limit as x approaches negative infinity is equal to the limit as x approaches infinity is equal to, and then whatever that value is.
What?
I guess I should write of f of x, technically. Okay, they have to be equal. The number is whatever your horizontal asymptote is. So this is just equal to 3.
I'm gonna sit here and practice my making sense. These are just
Okay, and part of this is because If you put negative infinity on top for x and on bottom, okay, we can ignore the -2 and the -1 or the stuff that's being subtracted. At infinity, those little numbers are not going to make a difference, okay? So you've got 3 times negative infinity over negative infinity. Those negative infinities essentially are canceling, which give you 3. So that's why this is happening, okay? So if you need to actually see it plugged in, that's what's going on, okay? You're just plugging in negative infinity for x, and you can ignore the stuff that's out being added or subtracted because it doesn't matter. You're just looking at the highest powered terms when it comes to that because nothing else is going to make a difference.
Okay, so when you're doing the one for the horizontal one, it's always how do I'm still confused.
What do you mean?
So it's the limit as x approaches negative infinity is
Equal to the limit as x approaches infinity. Because I told you up here that they're equal.
okay.
Because they're both equal to the same thing. They're both equal to b. Because they're going to cancel.
So you have to write the whole thing though,
Yeah.
but you eventually just get to the.
Because you're technically showing that you checked it.
Okay. So the only hard one practically is the vertical one.
Basically, yes. So we'll do one more of those ones. So number 10, or well, yeah, we're going to do one more of this problem. So f of x is equal to 4 minus 3x over x minus 5. Just to not, if it's confusing for you by the fact that on top the x is listed second, you can rewrite it as negative 3x plus 4 over x minus 5. If you can see it as it is, you can leave it. If you need to move it, that's how you would move it. Okay, just swapping the top terms, just make sure you keep the signs with them. So with this one, where's my vertical asymptote?
X equals 5.
X equals 5. How about my horizontal asymptote?
-3.
Y equals -3. So then your limits
Oh no.
as x approaches 5 from the left of f of x is equal to what? So you're looking at like 4.999.
So it's negative on the bottom. And it's negative on top. So it's positive.
So it's positive. And then the limit as x approaches 5 from the right. So like 5.001.
Positive on the bottom. Negative on the top.
Yeah.
So it's number.
So negative infinity. And then your limit as x approaches negative infinity of f of x is equal to the limit as x approaches infinity of f of x is equal to what? -3.
That's not that bad.
They're not bad. All right. Basically, for all the problems, I'm giving you the same instructions. Is just find vertical and horizontal asymptotes and then find their end behavior. That's really all that, regardless of what the instructions say, that's what you're doing. So other than the very first problems where it's just asking you for domain, that's the only ones that are actually doing what it asks for. So 20 f of x is equal to 3x squared over x squared plus 1. So vertical asymptotes.
positive 1. Well, x equals. Wait, no. Wait.
Is there anywhere that the denominator is equal to 0? Real numbers?
So.
No, so if I did x squared plus 1 equals 0, x squared is equal to -1. If I take the square root of that, that's i's, so there's not a vertical asymptote there. So you still have to show that you checked for them, okay, by telling me that there's none. Don't just not write it, okay? It's not correct if you don't tell me that there are none, okay? How about horizontal asymptote?
3.
Y equals 3.
I'm sorry, I never had the beginning.
So then there's no vertical asymptote, so I'm not checking any in behavior for vertical. So I'm just doing the limit as x approaches negative infinity of f of x is equal to the limit as x approaches infinity of f of x is equal to what?
3.
3. Okay. 24. So you're going to have to do 23 for homework. So 24. So for 23 and 24, there's one other thing that you need to do besides your asymptotes here. So I just need your asymptotes and I want the intercepts. Okay. You don't have to do in behavior for these ones. Okay. So you need to do in behavior for the other ones that we've done, but not for 23 and 24. So we're going to do 24 really quick, and then y'all have 23 for your homework. So 24, g of x is equal to x plus 2 over x squared plus 2x minus 3. So vertical asymptotes. Set the denominator equal to 0. Is this factorable? If so, then what is it?
The square root of positive or negative.
I need to factor it first.
X squared minus 1 plus 3. Oh, I'm sorry, there's x's there? Wait, no. Give me a minute.
So this is positive, this is negative, so the factors are 3 and 1. It's going to be positive 3, negative 1, so x plus 3, x minus 1.
You can do a lot faster than I think. So. Wait a minute. Oh, duh.
So x equals negative 3, x equals 1. Okay, are your two vertical asymptotes. What is your horizontal asymptote? Bigger on bottom.
None. No, bigger on. Wait, that's bigger on top. Never mind.
Y equals 0. So then to find your intercepts, okay, for your x-intercepts, we set y equal to 0. For y-intercepts, you set x equal to 0. So for x-intercept, we set, by setting y equal to 0, the whole bottom is going away. Because the whole bottom times 0 is 0. So all you have to do is look at the top. So x plus 2 equals 0. So x equals negative 2. So that means your x-intercept is negative 2, 0. Y-intercept, you're putting a 0 anywhere you see an x. So 0 plus 2 over 0 plus 0 minus 3. So that's negative 2/3. So 0 and negative 2/3. Okay, so your problems are 1, 7, 9, 11 through 14, 19, and 23. Due tomorrow.